Jai Hind everyone. I am Shruti Jain, Assistant Professor, MCA Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that we are going to discuss today talks about the software characteristics, components, applications and the qualities. This topic comes under the software engineering subject and the subject code is KCA 302. Now before starting with what a software exactly is, we'll first discuss what is exactly a program. Because when we have multiple programs lined up together or combined together, we get a software. So it is very important to understand what exactly is a program before we proceed to what is software. So a program, it is a set of sequential logical instructions. So whenever we are talking about a program, as you might have developed some of the programs in your basic languages that you are learning, that could be C, C++, Java or Python. So it is a sequential instructions. The instructions are given in a sequential manner and they are based on some of the logics. That is why a program is a combination of both the sequential instructions as well as which contains the logic. Now, when we have a combination of programs together, we get a software. It also includes some more things. So, a software is a set of items or the objects that form the configuration, which includes the programs, the documents and the data. Now, programs are the set of sequential logical instructions which a lot of programs or a lot of instructions joined together form a software. Then we need some of the documents which will document what exactly those programs are doing, because only building the program is not enough, it is not sufficient. Instead, you need to document it for further use or for future use, because it might be a possibility the program that is being developed by one person, it is read or it is altered or changed by some other person. So it is very important to understand the basics, what that program is doing. So that can only be able to, that can be defined in the documents, and the data, on what kind of data you are working on. So if we talk about this definition is taken from Software Engineering, a Practitioner's Approach from the book Pressman, 5th edition. Or if we go in a more detailed manner, software consists of the instructions that we have already discussed are the computer programs, which when executed together provide desired functions and the performances as per the user's requirements. Then it also talks about the structures. It also consists of the data structures which enable the program to adequately manipulate the information. Adequately manipulating the information means we might be using different data structures which would be combining different informations from different places, and they can manipulate it. Like, if suppose we want to store the information in a form of a stack or in the form of a queue. So all those storage of information is based upon a particular data structure, or we might be using the graphs for our programs or for our softwares. So it also includes the data structures. Then the third one, as we have already discussed, it consists of the documents which describe the operation and the use of a program. Because only just making the program or only just making a software would not serve the purpose. We also need some of the documentation so that it could be easy for the other members to understand what is being done in the software and at what level it is being done. So if we look the invisible parts. So these are only the concrete parts of the software that may be seen, as we have discussed previously. Because if we look here, the computer programs can be seen because these are visible either to the programmer. The data structure is again visible. The coding part or the logic part is visible to the developer. The documents are visible to the developer team, the management, or the people who want to understand what is being done in the software. But some of the invisible parts are also there, which are being included in a software. So the first one is, software is the dynamic behavior of programs on real computers and auxiliary equipment. Now, we have developed a software, but it might be a possibility that they might behave differently on different platforms or on different equipments. So when you are working on a software, the type of software that you have built for a specific hardware, it might be a possibility that that software might not run properly on the other type of hardware. So it is dynamic in nature. The program would be same, but because of the configurations or because of the requirements of the system, they might behave dynamically, they might behave inappropriately or not as per the user's expectations when you are working on the real computers on different hardwares, or you are using some auxiliary or secondary equipments. Then it is also a kind of a software product which is a model of real world, and the real world is constantly changing. That means, suppose you have developed a software today, but because the technology is changing a lot, there is a change in the ideas or the way the things are being implemented. It is constantly changing. That is why we, at one side, we are saying that the software is a model of the real world. What is being represented in the real world is being transformed into a software in one or the other way. But because the real world is constantly changing, that is why we cannot rely on a software for a very long time. The software would also need consistent changes because the real world is constantly changing. Next, software is a digital form of a knowledge. Yes, because we are not getting anything in the hard form. It is intangible. It is a digital form of a knowledge. Any knowledge which you can get from the usage of the computer, that is a digital form of a knowledge. So if we look into the invisible part, till now we have talked about the visible parts, that were the instructions, the data structures and the documents. Here we talk about the invisible parts, which talk about the dynamic behavior of the programs or the dynamic behavior of the software, because when you are running that software on real computers, it might behave differently. Next, it is a model of the real world, but because the real world is constantly changing, that is why we cannot say that the software product is actually a model. It also needs changes on regular intervals. Also, we cannot touch and feel what a software is. Therefore, it is a digital form of a knowledge. So when we talk about the software, the computer programs and the associated documentation such as the requirements, the design models and user manuals comprises a particular software. So software doesn't mean only the coding part. Nowadays, the software talks about the programs, the programming part, as well as the documentation part, which includes the requirements. Now, requirements would include what the user actually wants from the developers to develop in a software, the requirements of the customer. Then the design models. What are the different models on which you are working in order to design a particular software? It never happens that whenever the requirements are given to you or the developers, these requirements directly go into the coding phase. Before that, we have the designs that are being created to understand how these requirements are being implemented, and only then, once everything is being finalized, only then the project or the programs or the software moves into the coding part. And then the user manuals again. User manuals are also very important, because until and unless the user does not know the functionality of different parts of the software, he will not be able to take the full advantage of what the software is developed. So user manuals again is a part of the documentation, which again comprises of the software. The software products may be developed for a particular customer, or it may be developed for a general market. So on the basis of this, because the softwares, the demands of the users are many, so we have the different types of softwares which may be developed for a particular customer, that are known as the custom softwares or the customized softwares, or they could be the general software for the general market. It could be a businessman who would be using, or a programmer who would be using, or a layman person who would be using. So those are for the general market. So for those type of audience or those type of users, we have the generic softwares. So coming to the next point, the software products may be the generic products or the custom products. The generic products are developed to be sold to a range of different customers. For example, we have the softwares like the Excel or Word, which even a child can be using, or a programmer can be using, or a senior citizen might also be using. So these are the general purpose softwares which are used by the general people or the generic customers. Then we have the bespoke softwares, that are the custom softwares which are developed for single customer according to their specification. It could be a single customer, or it could be like a group of people or specific group of people who would be using a particular software. So new softwares can be created by developing new programs, configuring generic softwares, or reusing the existing softwares. It is not the case that every time when a new software is to be developed, it is to be developed from a scratch. It could be you can develop it from a scratch if that is a new idea or none of the idea has been implemented of the same type before. Or you could configure the generic software and you can extract some of the information which you need, or reusing the existing software. Already built softwares are available. You can reuse them for your own purpose. So if we look over here, we have the components of the software. The first one talks about the programs, the documentation, and the operating procedures. These operating procedures are basically all those procedures which help you in operation of the software. The programs and the documentation we have already discussed. So these are the three important parts, which includes the data structures as well, the operating procedures. These all three talks about what exactly a software is, or the whole of the composition of a software. So coming to the characteristics of software, the first one is software is developed or engineered. So the first point talks about that the software is developed or engineered, but it is not manufactured. It is not manufactured, reason being, it is not a hardware, or it is not something which you can touch or feel. Only the products or the hardcore products or the softwares are manufactured. So software is not that part. That is why it is developed or engineered, where the programmers work upon different programs and they develop a software. Next, the software is malleable. Malleable means it can be changed easily. So if we compare it with the hardware, whatever product is being developed, you cannot change it as per the user's requirement. It needs to be manufactured again. But when we talk about a software, it can be changed easily as per the user's requirement without making changes in the whole of the software. But again, it depends upon the requirement. Then, software construction is human intensive. Human intensive means it depends upon human to human. Like if I want to develop a software on a particular system, then the way my thinking process is working on would be different from the other whose thinking process would be going in a different direction. So whenever a person or the team who is developing a software, it is again dependent upon their IQ level or their thinking, how a software construction takes place. So it is human intensive rather than based on different processes or the different procedures which are used to develop a particular software. The next, software is intangible and it is hard to measure. Intangible means you cannot touch and feel. It is just a thing which works on code, or it is in the digital form, but it is not in the physical form available to you. And because the software is intangible in nature, because you cannot touch and feel the software, it is very hard to measure it. Measure it in the sense like you cannot identify what weight it has or what are the dimensions of the software. So those are the different things which does not exist for the software, because these softwares are intangible in nature. Then the software problems are usually complex, because we are working on such situations where where we need to develop a software because we are not able to handle some kind of problems which might be difficult to be solved or which takes a lot of time. So to avoid the wastage of time, we need some softwares to be developed. That is why we say that the software problems are usually complex, and the softwares are built only for are built normally for the complex problems. It directly depends upon the hardware, as we have already seen that the software might work differently on different hardwares, because it is not consistent. It might change. It is dynamic in nature. That is why it is dependent upon the hardware. The software that you are developing for a particular hardware will work fine for that hardware, but it might be a possibility that as soon as you make changes in the hardware, the software might also change, or the working of the software might also change. Software solutions require unusual rigors, sudden changes. It could be a possibility that once the software has been developed, but there might be a change in the requirements, or some of the solutions are to be incorporated. So it requires the sudden change in it, or a sudden decision making onto it, that yes, these solutions are to be included in a software. Most softwares are custom built rather than assembled from existing components. It is not necessary that every time they are assembled from existing components. These are also built for the customized softwares, or they could be built up from the scratch. So if we look here, we have the characteristic as the software doesn't wear out, but it will deteriorate. That means if we look into the hardware failure curve of the hardware, so how does it work when with the passage of time from where the hardware has started to be developed, the first few days of it comes out to be the burn-in phase. The burn-in phase means whenever you are launching a product, it might be a possibility that that product might be having some of the complexities, or the loopholes, or the non-functionalities. So this phase is a burn-in phase where all those faults are worked upon, and then comes the useful life phase of the hardware. So here it is normally a consistent curve where every hardware or every machinery has a stipulated time period for which it works fine. So that is a useful life phase. And then comes out the wear out phase, because once the life of a hardware gets over, it starts giving problems, and that is known as a wear out phase. So, but because we are saying that the softwares are intangible in nature and there is no wearing out in the software, that is why we say that the softwares are, the softwares don't wear out, but they deteriorate. How? Because see, once the software has started to be created, then when the user is using it, he might be finding out some of the errors or some of the changes are required. Now, once the user started using the software, because we know that the needs of the market changes very rapidly, they need a change. As soon as a change in the software takes place, again it starts from the beginning. You start with the next prototype. When next prototype is being developed, then again a change is suggested. That change will lead to again moving from the beginning, and so on. And at the end here, we'll get the actual software which the user wanted. So if we look here, we have the failure curve which is starting in this manner, and it is idealized with the time. Now we will talk about some of the application domains of the software. Now, software is a general term for various kinds of programs which are used to operate the computers and related devices. So the first type of a software that we have is a system software. It is a collection of programs which provide services to other programs. We have the infrastructure softwares like compilers, editors, drivers, operating systems, which come under the category of system softwares. These softwares are normally comes pre-installed into your system. Now, the next one that we have is the real-time software. These softwares are used to monitor, control, and analyze the real-world events that occur. We can have it in the form of the real-time softwares, like those are being used for weather forecast or for the military purposes. Those are the real-time softwares. So, if we talk about the computer science, real-time computing or reactive computing describes the hardware and the software systems which are subject to the real-time constraints. For example, from event to system response, there is a stipulated time allotted for each and every occurrence of an event and the response of the system. If the system did not respond in a particular period of time, then the lapse in the system or the lapse in the response would lead to a destruction. That is why these are very complex softwares. Real-time programs must guarantee a response within specified time constraint, often referred to as deadline. For example, the softwares that are required for weather forecasting. The next type of softwares that we have are the embedded softwares. This type of software is placed in the read-only memory, that is ROM of the product, and they control the various functionalities of the product. The examples that we have are the ATM, cell phones, printers, thermostats, calculators, video game consoles, or any kind of a thing where the basic part of that particular device is the embedded software. They refer to the computer programs that directly interact with the hardware. These programs are typically built to perform a specific function or to make the hardware perform in a specific way, and several pieces of embedded software may be built into a single piece of the hardware. Embedded software is an integral part of the hardware into which it is built. It could be an automobile security system, signaling systems, etc. The next one that we have are the business softwares or the business applications, which are used for the business purposes. These are the set of computer programs used by business users, and they perform various business functions. These applications are used to increase the productivity, to measure the productivity, and to perform other business functionalities accurately. So, for example, we have the content management system or the ERP or the customer relation management system. The next one that we have are the personal computer softwares. These are the softwares which are used in personal computers. For example, the word processors. These are the generic softwares normally, the computer graphics, multimedia animations. Then we have the AI softwares which make use of some of the algorithms to solve the complex problems, which cannot be solved straightforward. They need some analysis. So, for examples, we have the neural networks, the expert system. These all come under the artificial intelligence softwares. Then we have the web-based softwares which are used over the internet with a web browser. You do not need to exactly install them, but they can or download any software, but they can be used only through a link, or a web-based email program could be an example of the web-based software. For example, HTML, Java, the emails, Gmail, Hotmail, Yahoo Mail, these all are the examples of web-based softwares. Engineering and scientific softwares, huge computing is normally required to process the data, for example, CAD/CAM, circuit analysis, etc. Now comes the concept of software crisis. This is a term which is used in the computer science to describe the difficulty of writing useful and efficient programs in the required time. Now, software crisis is this basically occurs because it might be a possibility that the same workforce has been developing the softwares for a very long time. They are not upgraded with the latest technologies or the methods or the tools. It could be one thing, or it could be like the over budgeting of the softwares. The estimation of the cost was not done in the beginning of the software, in the beginning when everything was being discussed, and later on it moves for the over budget. Or it could be you were not able to, the developers were not able to complete the software in time. It could be time lapse. So, with the increase in software complexity, many of the software problems arose because existing methods were insufficient. So, here are some of the reasons which led to software crisis. The first one is the increasing demand. Sometimes it happens that because the things are getting complex day by day, so there is an increase in demand of the softwares, and we have a certain limit of the developers who are developing those softwares. That is why the demand that is generated from the customer's point of view is not able to be covered up. The supply is less as compared to the demand, which leads to software crisis. Then increasing complexity, because the world is changing, the technology is changing, the things are becoming complex day by day. Due to the increase in the complexity of the softwares, the developers might not be able to handle those kind of complexities, which again leads to software crisis. The challenges are increasing with the increased complexity, which again leads to software crisis. The workforce remains the same with not updated tools or the methods or the knowledge or the technologies, which again leads to software crisis. Same methods and same tools are being used for a very long time, which might have become outdated. So, that again leads to software crisis. Now, the symptoms for software crisis. The 20% of the client server apps, these are abandoned or restarted from the scratch. 30% of the apps are significantly altered to avoid the disaster. And the 50% of the apps are delivered significantly late. What could be the causes? It could be the software fails because it crashes frequently. All the exceptions are not handled properly. It is expensive. Then it is difficult to alter, debug and enhance because the softwares are very complex in nature. So it becomes very difficult to alter them after a certain point of time. They are often delivered late, or they used the resources non-optimally because the actual planning of the resources was not done in the beginning. The software professionals lacked engineering training. They were not updated with the latest technologies. The programmers have skills for programming, but without engineering mindset about the process discipline. They are not motivated to develop a software. They have the programming skills, but the motivation is lagged. Now, till now, we were talking about the software and the programs. Now, let's discuss something related to the software products. The software products are the things which are being delivered to the user, but a program is basically one single set of instructions which is being developed for a particular execution or the particular problem. So, here we have the differences between the programs and the software products. So, the first point says that the programs are usually small in size, whereas the software products are large in size. The author himself is a sole user. Only the person who is creating a program can be the user, or there are one or two more users. But when we are talking about the software products, there we have the large number of users. For programs, because only the author is there, so there is a single developer. But when we are developing a software product, we have a team of developers. Programs lack proper user interface because it might not be required to have the user interface because it is for a very small purpose. But when we are working on the software products which has a lot of interfaces which connect one page to another, so we need to have a well-designed interface. Programs lack proper documentation because it is just a program. It is not required to, it might not be needed to document it or give the detailed explanation of that program. But when we are talking about the software products, these are well documented and user manuals are prepared so that the users can understand that product. And not only the users, the people who are maintaining that software in the long run may also understand what is done in a particular module of a software. Programs are the ad hoc development. Just a thought came and you started working on the program. But when you are working on the software product, it is a systematic development. It needs a lot of things starting from the planning phase, then collection of the requirements, then collection of the requirements, then designing different things, like we have the use case diagrams, we have the ER models, all those designing part, the classes are being designed. Only then it moves into the coding phase where the whole of the software is coded using a particular platform or a programming language, considering the front end and the back end. Once that coding part is done, then comes the testing phase and later on the maintenance phase. So this is a systematic development because the software is a very large thing that is being required by the user, but programs are just a very small piece of instruction. So it may start with a ad hoc development. Now we have the software myths from the customer perspective. Here, when we talk about the software myths, there are three types of, the myths are from three different perspectives: the customer, the producer and the developer. Customer, the developer and the management. So starting from the customer perspective, so a general statement of objectives is sufficient to get started with the development of software. So the customer thinks only you just tell that I want the software to be prepared or to be developed, then the developers would be developing at their own end. That is not the case. The second one, software is easy to change, which again is not feasible because it is only the developer who know how complex the software is. Software with more features is a better software. That is again a wrong thing. Only the you need to have only those features that you actually require to be included in your softwares. From the developer's perspective, once the software is demonstrated, the job is done. That is again not true because the software then enters into the maintenance phase, which needs a long-term maintenance of the software. Until the software is coded and is available for testing, there is no way for assessing its quality. That is again not true. The planning stage, again, the planning and the designing phase have their own ways to assess the quality of the software. The only deliverable for the software development project is a tested code. Nowadays we have the user manuals, the documentation part also, which is given to the customer for use or for in support with the software. From the management perspective, as long as there are good standards and clear procedures in my company, I shouldn't be too concerned. Though the good standards and procedures are provided, but if the skills are not provided, or if the mindset of the developers is not proper or they are not trained, then these standards and procedures are of no use. As long as my software engineers have access to the fastest and the most sophisticated computer environment and the state-of-art software tools, I shouldn't be too concerned. But along with this, the software engineer must have a proper mindset and the motivation to work for a particular goal. That is why just providing the standards, clear procedures or state-of-art tools would not serve a purpose or would not result in the development of a good software. Now we have the 3 P's, that are the project, product and the process. So project is a sequence of tasks which are planned from the beginning to end, and these are bounded by the time, resources and the required results. The product is what is delivered to the customer. It may include the source code, the specification, the documentation, etc. The process is a way or the procedure in which the software is produced. It is a collection of activities that lead to the development of a certain part of a product. Now the role of management, again, here we have the people, the project, the product and the process. So when we talk about the people, the software development needs good managers. They increase because they increase the probability of success. When we talk about the product, it is a solution to customers' problem and it is an alternate, hence the objective and the scope of the work should be defined clearly. Alternate solutions also need to be discussed. If suppose this is a problem and this is a solution, if this doesn't work out, how would be the alternate solution possible? The process, a way in which a software is produced. Many life cycle models and process improvement models are available. For the project, a proper planning is required to monitor the status of the development and to control the complexity. Concrete requirements need to be defined and freeze so that they are not changed at the later stage. That's all for today.